Hello students, myself Dr. B. Sridhar, Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Now, we are going to discuss about light emitting diode. In the optical fiber communication system, there are three major components to transmit the optical signal from one place to another place. One is optical fiber, second one is optical sources, third one is optical receivers. The first one is the optical fiber is the fiber here which can be propagate the signal. Second one, the optical sources. The optical sources, here we can use either LED or laser source, because conventional sources are electrical, but we need to convert the electrical signal into light signal, the light signal in the form of either it may be the LED or laser. Now, we are going to discuss about light emitting diode. See, as I said earlier, so LED and laser are the two major optical sources to achieve the optical communication system efficiently. Now, we will see light emitting diode and diode operating characteristics. Fine. Optical sources. So, in this LED, the LED is suitable for only the short distance and it is low bit rate applications. While laser, the laser is suitable for a long distance communication system and also it has high bit rate. So, generally for long distance communication system, so we can use laser sources rather than LED, but LED also efficient one to transfer the information from one place to another place. So, but here only the short distance and the lower bit rate. So, based on the applications, so we may use either LED or laser as a optical sources. So, now we will see light emitting diode. So, what is the light emitting diode? So, it is a specialized PN junction diode. We know that the diode is nothing but a combination of the PN type of material. Okay. So, it is a PN junction diode. So, made up of very thin layer and fairly heavily doped semiconductor material. So, this is very important point in the while discussing about the light emitting diode. Fine. So, another one. So, when the diode is in forward bias condition, we know that, so some cases we have a reverse bias and forward bias condition. Now, when the diode is in the forward bias condition, so the electrons from the conduction band will recombine with the holes from the valence band, so releasing some energy. So, generally for normal PN junction diode also same process. Okay. So, the electrons holes pair recombinations, but here the same only. So, the electrons and holes are recombined, but to produce a photon energy. So, this is a very important thing in LED. So, that is why called specialized PN junction diode. So, here initially I said it is a specialized PN junction diode because here also electrons holes pair recombination is occurring, but here it emits the photon energy in the form of light. So, that is why called it a specialized diode. Okay. So, here a thin layer is responsible for this photon can emit the energy and in form of the light as the output. Okay. So, this is very important. A thin layer is responsible for this photon energy and can be leave the junctions and can radiate away producing the light as the output. Okay. So, now we consider next one. So, the conventional PN junction diode, it is like a normal material, semiconductor material. Okay. So, here is a both side which has the junctions. So, here the one more thing, the electrons holes pair recombinations occurs in the layer of the 10 micrometer. And one more thing, the sandwiching. The another thing is important is sandwiching a layer. If you sandwich the P and N type layers, so here if you see the layer distance is only the 0.1 micrometer. Okay. the carrier confinement problem can be resolved by sandwiching a thin layer of 0.1 micrometer between the p and n type layers. Okay. So, this carrier confinement will occur due to the band gap discontinuity of the junctions. So, this is called a heterojunction and the device is called double heterostructure. Fine. Now, if you see the structure of the LED, now we know that the combination of p and n type material. Okay, so here the p type and the n type. So here this only the electrons holes per recombinations is occur and it can be emits the light energy. The emission of photon in the form of light. Okay, fine. So this is general structure of the LED. Okay, fine. Now, so what are the specialized material? So we are using in LED. That is very important. So now gallium arsenide. We are using proper here. Generally, we are using the three materials. One is the gallium arsenide. Second one is the gallium phosphide. Next one is the gallium arsenide and phosphide. So these combinations, okay, so will give the different applications of the LED signal. Okay, fine. Now let us take gallium arsenide. So the gallium arsenide, so which forms this material form a signal. Okay, so generally these LED sources are used in the remote control. So we know that in the remote control also at the bottom we have the LED bulb. Okay, so that material, that LED is made up of the gallium and arsenide. And next one, if you see the LED in real time application, if you see the LED, so which has different colors, the white color, red color, green color, blue color, etc. Okay, so these all are formed depends upon the material. Okay, so if we choose gallium phosphide, so we can obtain either red color light or green color light. Okay, so next one is gallium arsenide phosphide. So this one is responsible for giving red or yellow color light. So majorly in the LED, if you see LED here, majorly you can see the red color light. Okay, so along with red color, so here we can able to generate the green, yellow, blue, etc. depends upon the material we are employing in the LEDs. Okay, fine. Now let us see the homojunction diode and heterojunction diode. The homojunction diode is a normal one. So the homojunction diode, if you see the PN junction diode, from the single semiconductor material, it's a homojunction LED. Okay, so the homojunction LED or the surface emitter give off light from the edges of the junction as well as the planar surface. See here the light from the edges of the surface. So we know that here the n-type material, here the p-type material. So this is a sandwich here we are having. So this junction the light can be emitted out. But the thing is that in the homojunction LED, so we have the low radiance at the output. So that's why, so here we can prefer the heterojunction LED. So what is the heterojunction LED? So here along with p and n type, here in middle sandwich, so here we are using the indium gallium arsenide phosphide kind of material which form the heterojunction structure. So this heterojunction structure will form the similar crystalline structure but different energy level and also which has different refractive index. So due to this, the difference in the confinement layer and produce more directional output for the light. The thing is that the most important thing in homojunction and heterojunction is the directional output of the light. In homojunction, the directional output of light is very less. That's why you can say it's a less or low radiance of the output. But come to the heterojunction LED here, so due to the sandwich of this P, N and another N, okay, so due to the introduction of some indium gallium arsenide phosphide, So what will happen? The difference in the confinement carrier and produce more directional output for the light. Results, it gives a high radiance output. Okay, so we can prefer only heterojunction LED for higher radiance output. Fine. Now see the band structure. So generally we know that the metal contact. Okay, so here this is N-type material, here the P-type material is there. So here we are using the different combination of the N and P type. Okay, so this is a heterojunction layer center on. Okay, now here if you see, here see the radiance, so here no radiance, nothing. Okay, so if you see this electrons holes per recombination is there, here see the here active region is more only in this region. It is very important in the band structure. The same like the metal contact on both the side, the N-type and P-type material. So here the sandwich, so here we see here N-type, here P-type, again here N-type, here P-type. So this is the centralized region, so which gives the more directional output as a light. Okay, so if we consider this one here, if we see here we can get the high active region, high output at this region. Okay, so this heterojunctions, this band structures tells about the, so which band, which region, which are the high radiance of the output. This is one of the important concept in the optical fiber communication system. So generally LED and laser are the two major sources. LED is using for the short distance communication, laser for a long distance communication. Thank you.